Hi guys, welcome to CS50 Caesar's walkthrough tutorial hints and clue. So today we're gonna explain how to resolve this problem. We will divide this into two sections. So first we're gonna understand more about the program. Second, we're gonna understand about the pseudocode. So the 1.1 we start to understand the program by using the uppercase as the example. So we can see this example here. The user key ins 1. So the plaintext user key in is ABC uppercase. So our program will convert and the text into the cipher text BCD. So behind the scenes is that the plaintext ABC, when we convert inside the program, will convert into a decimal. So the decimal for the ABC is 65, 66, and 67. So when the key is 1, the A will convert to 65, and the 65 will plus 1 into the 66. So the 66 will look to B. So that's how we get A to B, B to C, and C to D. So the second example is also similar, is that the difference is the key is 2. We are still using the uppercase. So the same concepts. So the A will convert into 65. 65 plus 2. So we'll go to 67. 67 will go to C. So this is how we get C here. So we convert into the ciphertext into the CDE with the key number 2. This is the uppercase. So the second slides will talk about lowercase and also symbols which are not alphabets. So the first example here is, the difference here is we have a lowercase and an uppercase. So what we can see here is the lowercase, the decimal, is different number as the uppercase. The lowercase and the uppercase have different decimal number. For example, the A has 97, the uppercase A has 65. So we can see that there's a difference here. So the same concepts apply. The A will convert to the decimal 97. 97 plus 1 into the 98. So the 98 will go to B. So that's how we get the B here. So we notice that the A and B, the concept is the same, but just that the decimal is different. So let's look to the last example here. So we explain the lowercase and the uppercase, and now we talk about the other symbols. So the symbols here will not change. As you can see, the ciphertext is the same here. So this explain that we don't have to consider to convert the plaintext to the ciphertext in considering with the symbol we are not alphabet. So what we have to focus here is the uppercase, lowercase, and the symbols which are not alphabets. So we have to separate these two categories here. So before we go through more the pseudocode, so we have to also understand the command line. So we saw that here there's these two terms here. So we explain what is it. So argument counts is actually the numbers of arguments passes to the program. And argument vectors is actually an array or string. So for example here, you can see this is a command line here. You can see the argument counts is actually floor. So it's 1, 2, 3, 4. So the argument vectors is this one, /Caesar 1 x z. So for the vectors, we also can have an index. So index 0 is /scissors. So index 1 is 1, index 2 is x, index 3 is z. That's how we derive from these two, from the command line with these two terms, argument count and argument vectors. So now we're gonna go through the pseudocodes. So I will explain one by one here. So these pseudocodes we can find in the problem itself, in the hint sections. So first we're gonna have the one command line arguments. So the goal here is to determine that the user provide exactly one command line arguments, then we print success. If the user do not provide any command line, or they provide two or more, this is exactly not what we want. So we'll print out this result here. So from here we were gonna use a method called if else. So if the condition is true, we print this output. Else we print this output. So it's quite similar to here. So we also can use the concept that we explained just now. So argument vectors and argument count. So how to determine that the user provide exactly one command line? So we can count the vectors using the index. So this is 0, this is always 0. So this is 1. So for example, there's more here, so it's not what we want. If there's no index 1, that is also not what we want. We want exactly one command line. So this is a hint here. So go to 2.2, we have to check all the characters are digits. So the goal here is to check all the key here is digit, not letters, not symbol, not space. So how we're gonna do that? So the method here is gonna use a for loop here. And we also use the string.h, the string length. String length is actually used to calculate the length of a string. So after that, we can use the if-else statements. We also will use the ctype.h to find each digit. So for example, if this is a digit, so the statement will become true, or else it's false. So we also have to use some kind of a tracking concepts to track, for example, 1 here, 2, to make sure all this is a digit. So this is 2 examples. For example, if the user key in 20, so this is what we want. So we're going to print a success, and we also repeat what the user type in, string here. So after, if the user keys, for example, alphabets here, you can't see, so because it's red color. So if the user is keying XYZ, so it's not a digit. So we will feedback to the user that this is not what we want. Alright. So this is the basic, the concept. Okay. So we're gonna include these 2 library here. Just now we talked about the tracking system. We have to initialize integer track digit equals to 0 here. 0. So the for loop I equals 0 and equals to string length string x. So what is this string x? So string x we can see is directly linked to here. It's a string. So it's gonna do with this vector here. So you can see which one we want to find. Of course we're gonna find here. So it's something here. So we're going to put a string length here. We need to determine what is the length of the string. So once we find the length, we can put all the parameters here. So if the string here, for example, let's explain what is this. So if the digit here is a string, is a digit, so it's considered pass. So we put an example, for example, argument vectors index 1, 0. 1, 0 is actually 2. So argument vectors 1, 1 is 0. So it's 2, 0. So for example, if these two value, for example, this round first, if this value is digit, so this track digit will add 1 here. So if the second statement is true to, so it will become 2. So imagine once we loop all here, we get the track digit is equals to 2, so we put a 2 here. So if this track digit is equals to the string length of this string, so this string length is actually 2 because there's two number here. So we already can conclude that all the string inside is all contains digit only. So they will print success. We also can print the string here, as just now what we mentioned here, we have to print back the same string. So else we have to prompt the user that is wrong. So basically this is the concept here. So the 2.3 we would have to convert the command lines arguments from strings to integer. So our goal is convert the string to integer. As I mentioned here, the argument vectors is actually an array of string. So we have to convert the string. For example, this is a string, we have to convert into integer. So how we're going to do that? We're going to use a method called ATY. I'm not sure whether is it pronounced correctly. So we're going to use this library here, these functions here. So how we're gonna apply this is something like that. We have to include the library. So we have to initiate declinations, the string, integer, the variable. Okay. So once we decline the variable, we have to equals to the string that we want to convert. This is how we convert a string into an integer. Alright, so I hope this is clear for this slide. So the 2.4 is we're gonna prompt the user to key in the plaintext. This is very simple. I think we already go through that many times. CS50.h use the get string. So I have to include the library here. We have to decline the variable in the string. So use the formula here, get string. So this is how we store the user input data for the plaintext. So the fifth is a slightly complicated one. So we have to iterate over each characters of the plaintext. So first, before we go into details, we have to understand how it works more detailedly. I think this is something that I explained just now, but this is try to let you understand more. Examples, the same as similar examples. The user key in 1, and the plaintext is AA, and the symbols and exclamation marks. So the text here with what the user key in here, so we will convert into the decimal. So this is the decimal for each alphabet. So we notice that the uppercase and lowercase is different number. So as I explained just now, uppercase and lowercase is different, but we don't have to consider the not alphabets. So our program should not change anything for the non-alphabet. So you can see for alphabet there's a +1 for the decimal because the key is 1. So it will convert back to the ciphertext that we wanted. So basically this is just explanation again to refresh again before we go through the formulas. So alright, so the goal here is to iterate one by one of the plaintext. So we have divided into 3 categories: the uppercase, lowercase, and others, which are non-alphabet. The methods here will use for loop, string.h, string length, and ctypes.h, is alpha and is upper. This is the formula here. So there's a slightly different formula that the CS50 given. This is, I'm not sure whether you guys have the same formula as me. This is what I created. So this is C is ciphertext. Ciphertext means, for example, what we want to find. A P is a plaintext. For example, the user key in A. So A is a plaintext, but you have to convert into the decimal. So the case is we have to determine whether it's an uppercase or lowercase, and K is a key. So basically this is the formula here. This is the same thing that what I taught just now. Is uppercase and lowercase is different value. This is the example that to show you, to let you to understand more. So if the key is 1 and the P is Z, the uppercase Z, then what is the C? The C should actually go back to A as what the requirement. So for example, you can see the Z is actually 90, so we put 90 here, minus the case is uppercase, that's why we use 65. So 90 minus 65 plus 1 is the key, so the modulus 26 plus 65, there's a bracket here. So once we minus the case here, we become 25. So the key we have to plus 1. So 1 with plus 1 is 26. 26 with 26 will become 0. So 0 plus 65 is equal 65. So it means A. This is actually what we want here for this problem. So let's go through the concepts here. So we have to include these 2 libraries. So first we're going to use the for loop here. J equals 0, M equals to string length. The plain here. The plain is here. You have to know the string length of this plain. So this is how we get the string length here. So J is less than M and J++. So from here we have to categorize into 3 categories here. So if, for example, if this is a alphabet, is uppercase, so it's not uppercase, so it should go to this category. So we talk about B first. So B is definitely fulfill these 2 categories. So we go to the next steps, which will apply the formula here. So what is this? For example, plain J. Plain J initial is 0, so we can count from 1 here. So we'll go through one by one the index of this string till the end. So for example, let's talk about B. It could be like 2 here, index 2. So B is 66. So do the formula here. So what is this? This is what we learned just now, I think. Let's see. Yeah. So when we convert, is actually a string. The string convert to the integer is the key actually. So this is actually the key here. But it's already converted to integer. So we just have to apply the formula. When we apply the formula, we auto converts into this text here. So this is the measure of the formula. So else if, so basically I do the first one for you. So you have to try to figure out these two by yourself. So this is almost a similar same concepts. So this one is, beside these two, this is what we're going to print out here. Non-alphabet as it is. So you can see the non-alphabet is the same. There's no changes here. So this one is also include a 2.6. We have to print a new line after we convert into the ciphertext. Important, we have to put return 0 here as a success. If failure, we have to put 1. Okay, I think that's all. Thanks for watching, and I hope those tips will help you to solve the questions more easily. And thanks for watching, and happy coding, guys.